This is part 6 of section 3.4. This is a different type of problem. We are given some information about the type of polynomial function we have, and we're trying to find the one that goes along with the information we have. Okay? Now, what we know for this one is we want a third-degree polynomial. So we want to end up with something that eventually looks like ax cubed plus bx squared plus cx plus d. Okay? Now, don't worry about the a, b, c, d, that kind of stuff right now. We want to end up with something basically like this. Okay? Now, what we are told is that 1 and 5i are zeros. Okay? And remember that when we're talking about zeros, if I came back up and I looked at this thing, you get your zeros, like 3 was a 0. That means it factors with an x minus 3. Okay? If I had x minus 2 as a 0, that would tell me that I could do x plus 2 as one of my factors, because it would be x minus a negative 2, which gives me x plus 2. Okay? Now, I want to come up with this. What I know is that 1 is a 0, 5i is a 0. I know I should have 3 zeros. What you need to remember is that if you have one complex solution, you always have another. So if 5i is a 0, then I know automatically that negative 5i is also a 0. Okay? Now, f of negative 1 is equal to negative 104. We'll come back to this later. Okay? So, what do I know? I know that this will factor with an x minus 1. Because if you set this equal to 0, you get 1 as one of your solutions. Okay? I know that x minus 5i is a solution. It is a factor. Because if I set this equal to 0 and solve it, I get 5i. And I also know that negative 5i is a solution, so this would become x plus 5i. If I multiply all this together, I'm going to get an x cubed, so this will give me a third-degree polynomial with 1, 5i, and negative 5i as zeros. Now, the one thing this does not take care of is you are allowed to have a multiplier in front, just a number, okay? And we will be able to figure out what this number is using this information. But they will want you to multiply everything out. So I'm going to start off by multiplying these two together since they are the more complicated ones. So I'm keeping the a and keeping the x minus 1. Okay? Now, multiply here, I'm just going to use distribution / FOIL. X times x, well, this is a difference of squares, really, isn't it? Because I have the same two terms, one with a plus, one with a minus. And remember, difference of squares looks like if you have a minus b times a plus b, or plus then minus, it always multiplies out to you square your first term minus you square your second term. So this would be x squared minus, because it's always a minus, 5i squared. Okay? Well, what is 5i squared? That would be 25 times I squared, and I squared is negative 1, so this is equal to negative 25. So what do I have right here? This is the same thing as a times x minus 1 times x squared minus a negative 25, so that's x squared plus 25. Okay, so this is getting better. Now I'm going to multiply these two together. And it's a distribution / FOIL. I keep that a. Now, x times x squared, that's going to be x cubed. x times 25, so that's plus 25x. Now distribute the negative 1. Negative 1 times x squared, that's minus x squared. And negative 1 times 25, that's negative 25. Okay, now normally we write this in descending power order, so we would have a times x cubed plus 25 let me start all over again here. A times x cubed minus x squared plus 25x minus 25. Okay, now all we have left to do is to figure out what this multiplier is. And here's where we use this information. So far I have this as my f of x, and I'm going to continue to improve it because I want to find out what that a is. But for right now, we're going to use this. This says if I plug in negative 1 for x, I should get negative 104. So let's find f of negative 1 right here. This is a times negative 1 cubed minus negative 1 squared plus 25 times negative 1 minus 25. So this is a times negative 1 cubed is negative 1 minus negative 1 squared is 1, so that's minus 1. This is minus 25 and minus 25. So what does this give me? That's going to be negative 50, negative 52. So what I have here is negative 50, negative 52a. Well, I know negative 52a, which is f of negative 1, is supposed to equal negative 104. So now I divide both sides by the negative 52. And you will get that your a value has to equal a 2. So our new and improved function, this is where we have right here. I know that a needs to be a positive 2. So my better f of x is 2 times all of this. And now distribute this 2 to get the answer that they want. That should be a cube there, miscopy. So that's 2x cubed minus 2x squared plus 50x minus 50. This is the answer they're looking for. This is the function that fits all of these criteria. Okay. Next problem, very similar. This time we want a 4th degree polynomial. I know that I is one of the solutions and 3i is another solution. Now I have 2 different complex solutions here, so that means I automatically know the others that work. If I is a solution, negative I is a solution. If 3i is a solution, negative 3i is a solution. This gives me all 4 of my potential answers. And I know that when I plug in negative 1, I get a 20. Okay, so starting off, my basic f of x is equal to, I have some number, some multiplier in front. And then I have x minus I, x plus I, or x minus a negative I. And then I have x minus 3, I, and x minus a negative 3i, which is x plus 3i. Now I'm going to multiply these 2 and these 2 because they are both differences of squares. Okay, so this gives me f of x is equal to a times x squared minus I squared, and I squared is negative 1. I'll get there in a second. And here that's going to be x squared minus 3i squared, so that's 9i squared. Remember, I squared is a negative 1. So I have f of x is equal to a times x squared minus a negative 1, so that's plus 1. And then here it's x squared minus a negative I, so that's x squared plus I, 9. Now let's multiply and distribute here. So I have a times x squared times x squared is x to the 4th, which gives me my 4th degree polynomial, which is what I want. X to the 4th plus 9x squared plus x squared plus 9. So my basic f of x is a times x to the 4th, combine like terms here for plus 10x squared plus 9. Now we're ready to use this so we can figure out what our a value has to be. If I'm going to find f of negative 1, I'm plugging this in here. That will give me a times negative 1 to the 4th power plus 10 times negative 1 squared plus 9, which is a times negative 1 to the 4th power is 1, plus 10 times, if you square negative 1, that's 1, plus 9. So I have 1 plus 10 plus 9, which is 20. So what I have here is 20a. So my f of negative 1 is 20a. And I know f of negative 1 is supposed to be 20. So my a value is 1. So technically, my f of x is 1 times x to the 4th plus 10x squared plus 9. And technically, I distribute the 1, but of course, that doesn't change anything. The answer they're looking for is x to the 4th plus 10x squared plus 9. Okay, now let's do one more of these. Again, very, very similar. I know I want a 4th degree equation, so I should have 4 zeros. And I know that if I plug in 1, I should get 100. Negative 4 is one of my solutions. 1/3 is one of my solutions. 2 plus 3i is one of my solutions, and this is a complex number, so that means 2 minus 3i is also a solution. Okay, so let's write this out. My f of x is going to equal a times x minus a negative 4 is x plus 4. 1/3 is a solution, so I have x minus 1/3. Okay, I have x minus, open parentheses, because this has a plus and a minus here, we're going to have a distribution to do. X minus, it's always x minus your 0, so x minus 2 minus 3i times x minus 2 plus 3i. Okay, so my f of x is equal to a times, I'm just going to keep these the same for right now, and here I'm going to distribute the negative, and here I'm going to distribute the negative. So I get x minus 2 plus 3i times x minus 2 minus 3i. Okay, so now I'm going to, let's go ahead and multiply these two together, and I'm going to multiply these two together. So this is going to equal a times x is x squared. X times negative 1/3 is negative 1/3 x plus 4x minus 4/3 times. This is a big distribution, and you will probably have cancellations in here because it did start off as a difference of squares, so we expect some cancellations. X times x is x squared. X times -2, -2x. X times -3i is minus 3ix. Now distribute the -2. -2 times x is -2x. -2 times -2 would be plus 4. -2 times -3i is going to be plus 6i. Now let's distribute the positive 3i. 3i times x would be plus 3ix. 3i times -2 is minus 6i. And then 3i times -3i is going to be minus 9i squared. Okay, so if you look in here, I have minus 3ix plus 3ix, those cancel. I have 6i minus 6i, those also cancel. I'm going to be able to combine these two because they are like terms. And minus 9i squared, that's a -1, so minus 9 times -1, that's the same as plus 9. Okay, so let's simplify, combine some like terms here. I have a times x squared, and then if I do -1/3 plus 4, if I get a common denominator and combine like terms, I get 11/3 x minus 4/3 times x squared. I've used that one. Minus 2i minus 2i, that gives me, minus 2x minus 2x, that gives me minus 4x. And then I have 4 plus 9, which is 13. Okay, so this is getting a little bit better. And I can go ahead and distribute all of this if I want to, but it might be easier if I go ahead and try to find out what a is. Because if a happens to be a number that will kill these fractions, my life is going to be much easier. So at this point, if I can go ahead and multiply out, or I can try to find out what a is. And I know that if I plug in 1, it should equal 100. So let's use this and plug in 1. So that would be f of 1 equals a times 1 squared is 1, plus 11/3 times 1 is 11/3, minus 4/3, times 1 squared is 1, minus 4 times 1 is minus 4, and then I have plus 13. So what does this give me? This is a times, well, this is going to be 7/3, this one is 10/3, times 1 minus 4 plus 13 is going to be a 10. So this is the same thing as, that's going to be 100/3 a. Now I know that 100/3 a is supposed to equal 100. Let's multiply both sides by a 3. And you get 100 a is equal to 300. Divide both sides by 100 and you find that your a has to equal a 3. Okay, so now I'm coming back up to my f of x to improve it. And I have 3 times x squared plus 11/3 x minus 4/3 times x squared minus 4x plus 13. Now really what I have here is I have 3 things multiplied together. These 2 things are fairly complicated, but it is still 2 things multiplied together. So I can choose any 2 of those 3 things to multiply together first, and I'm going to multiply these because this 3 is going to kill these 2 fractions. So when I distribute that 3, I get 3x squared plus 11x minus 4. Now I need to multiply this times x squared minus 4x plus 13. Now I just need to distribute this, combine like terms, and I'll have my answer. So this is going to be kind of a long step, but it's not really that difficult. 3x squared times x squared is going to give me 3x to the fourth, which is the fourth power that I knew I should have from the beginning. All right, 3x squared times negative 4x is going to give me minus 12x cubed. Multiply here to get 39x squared. Now I'm going to distribute this 11x, and while I do this, I'm going to line up my like terms to make combining easier. 11x times x squared is going to give me 11x cubed, so this is plus 11x cubed. Multiply here, that gives me a negative 44x squared. And then 11x times 13 gives me positive 143x. Now distribute the negative 4, and I get negative 4x squared plus 16x minus 52. Now I have my like terms all lined up, so I should get my answer quickly. My f of x is equal to, this should be my final answer, 3x to the fourth. That's going to give me minus x cubed. This is minus 9x squared plus 159x minus 52. And this is as ugly as this type of problem gets.